Hello, everyone. So we're going to get started with the first session of the 2020 SciPy Tools Plenary. This is to remind people what the format is. This is going to be 7 very short talks from a variety of projects highlighting recent work and what they're going to be doing. So we're just going to get right into this. First, we're going to have Nicholas telling us about Napari.
Hi, thank you so much, Tom, and thanks for the organizers. My pleasure to tell you about Napari. It's a multi-dimensional image viewer for Python. It's really designed for visualizing and interacting with kind of large scientific images. We leverage a lot of amazing tools in the scientific Python ecosystem to make this. We use a VizPy, a rendering system that uses OpenGL for very fast rendering in both 2D and 3D. We have a sort of full n-dimensional data model that supports visualizing very large array-like data. It can either be numpy arrays, Dask arrays, ZARs. We have an integration with an IPython console and Jupyter notebooks, and we have support for a variety of different fundamental image types that you use when doing imaging experiments. The team so far, we have a steering council of Juan Nunez Iglesias, who also contributed to scikit-image, Loic Ray, and myself, and a number of really amazing core developers, and a growing group of contributors. And we're really trying to build an open and welcoming community here, and we'll be at the sprints hoping to onboard new contributors that are interested in this project as well. I'll play this little video just so you can kind of see a bit of Napari in action here. We're visualizing a very large data set of some time series of cells. This is right now actually using ZAR and Dask to kind of dynamically load individual time points that you want to look at. You can kind of zoom in and out. We can also do 3D rendering. Before that was just 2D. Now we're kind of looking at things in 3D and a variety of other imaging features. So with that, I just want to say what's next. There's lots to do. We're adding better support for coordinate systems, multiple canvases, better remote data, more integration with machine learning. We have a public roadmap that's on our Napari website. You can in general get more information on napari.org. We're very active on the ImageSC forum, a forum for image analysis, and we're on GitHub and on Twitter as well. And so, as I said, we're going to be at the Napari sprint on the 11th and 12th. One of the teammates, Kira, also has a poster at SciPy as well. So I encourage you to check out her poster too. And with that, I just want to say thank you very much.
All right. Thank you, Nick, for being right on time. So next up, sorry. Is Emanuela in the room? So our next speaker is Emanuela Goyart to talk about scikit-image, but the system is telling me she's not here, so we're going to jump in order to Kyle Sundin to tell us about pyqt graph. And hopefully, so you can tell this is the first time we've tried switching speakers this rapidly in the system. When we're doing it in person, we all share a laptop and you then walk on stage. But I have to see Kyle is up here, and if you could share your screen.
Yep. So,
all right, so take it away, Kyle.
Hi, I'm Kyle. I'm from pyqt graph. So pyqt graph is a fast plotting library and general user interface in some cases as well. It's built with interactivity in mind. We have native Qt 2D rendering and 3D via OpenGL. We're primarily aimed at scientific and data acquisition applications. We're built on top of Qt and can be integrated into many different Qt applications. So some examples, we have all of your favorite styling options available and various ways to select regions of data as well. We have some powerful image handling routines as well. And like I said, we can render 3D images. So recently we've added some more maintainers. I came on in the past year or so. We've completely overhauled our CI, and we just released version 0.11, which was about 3.5 or 4 years after 0.10. 0.11 brings PySide 2 support, as well as better handling of date axes. There were 300 changelog entries and over 800 commits. We hope to get it out sooner than that in the future. So our near-term goals are to address our PR backlog. We've brought it down quite significantly. We were at about 160 a year ago, and now we're down to about 30. And then we're going to drop Python 2 and drop Qt 4 and prepare for Qt 6, which is due out in December. And from there, more frequent and smaller releases are on the horizon. So if you have any questions about pyqt Graph, please feel free to message me. I'll be on the Slack all week. And we also have a pyqt Graph Slack if you're interested in joining. Here are a couple links. I can post those in other locations if people are interested.
Okay. All right. Well, thank you, Kyle. So we're still having slight technical issues getting Emma on screen because the system tells me she's, oh, there she is. Vamping at a virtual room to kill time is difficult. But so next we have Emmanuel Goyart. I got that close to tell us about scikit-image.
Hi everyone. I'm Emma. I'm one of the maintainers of scikit-image. Scikit-image is the image processing toolkit for Python and science. It is best known for its simple functional API, completely compatible with numpy data arrays as images. Compared to other libraries, scikit-image tries to support a large variety of image modalities encountered in science, such as MRI or CT, that is 2D but also 3D images. Some algorithms even work for a larger number of dimensions. Scikit-image is application agnostic and tries to serve a community as large as possible. Therefore, we have a strong focus on pedagogical and example-based documentation. Since the last SciPy, we have made 2 releases, keeping the same rhythm of 1 release every 6 months. Through these 2 cycles, we've had an increased focus on documentation, and in particular, we are now starting to include tutorials based on realistic scientific data from application communities like life sciences or material sciences. For example, we just merged a tutorial on cell biology. This is possible now because we have a mechanism for fetching external images using the Pooch library. We have also worked on completing the compatibility of our API with 3D and ND images for whole modules like color conversion functions, which are now ND compatible, or specific algorithms like float fill, optical flow for registration, or edge filters. We have also added new features, and I've selected here 3 of them. One of our most popular functions is region props from the measure subpackage, which measures the properties of regions in an array of labels, such as the size, bounding box, or eccentricity. And we have introduced an alternative syntax for region props, allowing to return the properties inside a pandas data table for the compatibility with the data frame ecosystem. We have also grouped simple metrics and segmentation matrix function in a new metrics module. And last but not least, since parameter selection is one of the biggest difficulties in image processing, we have added a new meta function in order to calibrate denoising algorithms and select the best parameter automatically. All these features have corresponding tutorials in the gallery of examples, since this is a requirement for submitting a feature pull request to scikit-image. For the future, after 10 years of existence, we have started working on a 1.0 release. We have learned lessons from the past, and we will drop our range rescaling mechanism, which have confused users much more than helping them. We will also consolidate the API to be more consistent, even if this involves a few breaking changes. We are discussing this 1.0 changes on our mailing list if you're interested. In terms of features, beyond completing the compatibility with 3D and ND images, we have currently a big effort to include more image registration capabilities. Finally, we are part of a thriving numerical and data processing ecosystem, and we are trying to ensure better compatibility with upstream and downstream packages. As for upstream, we want to test different backends and numpy in order to accelerate the execution time of scikit-image functions. We are also collaborating with visualization and annotation tools such as napari or py-dash in order to build interactive tools for image processing. Of course, all this is done with our amazing community of open source contributors, and we have a sprint this weekend, and I hope to see you there. Thank you.
All right. Thank you, Emma. And next up, we have James Bednar, who will be telling us about holoviz.
Holoviz.
Holoviz, I'm sorry. And I guess
I'll share.
You sharing working? Great.
Looks like it is.
Gonna
Okay, yes, I'm representing holoviz. I'm just the figurehead. There are a lot of other people that I don't have time to list here, but if you go to holoviz.org on GitHub, you'll see everybody. Holoviz is a meta package or a meta project trying to coordinate between a lot of different projects. You'll see their logos down at the bottom of the screen. And the idea of holo is whole, entire, and complete. We're trying to address the entire problem of viz, which is not about just creating a particular plot, but about the whole life cycle of data as it arrives and eventually as it gets delivered as a final app or a final publication or whatever the final output is. And you can see our entire philosophy if you go to holoviz.org. Here I'm focusing on what's new in the past year. Last year we introduced Panel. Panel is designed at the tail end of this process. It's for exploring once you've got it available, the data available, and for presenting it as apps and dashboards, and using Jupyter or as a standalone deployable app. What's new in Panel is that it has easy templates for making quite nice looking apps and apps that are responsive and draggable, all sorts of cool things now. Basically letting you exploit things that have been happening in the JavaScript world, but easily from this fully Pythonic API where you don't have to think about anything but Python. And Panel has added the really important, amazing thing is that Panel and SciPy widgets are now fully compatible. This also involves making bokeh and holoviz fully compatible with SciPy widgets. And what that means is you can use an SciPy widget in your Panel app. You can use your Panel app as an SciPy widget. You can use your Panel app and deploy it with Voila, and so on. You can use your Voila app and bring that into Panel. So basically, all all the different back and forth are possible. We also show how to use panel with Flask now. Also added support for a lot of 3D support using BTK or deck.gl, which is, I guess, 2.5D, and greatly improved support for responsive layouts, progress bars, generating static apps, and so on. All sorts of cool stuff. Been a very busy year for Panel. Also, Panel works with any viz library. We ourselves maintain the holoviz and hvplot libraries. hvplot offers a pandas-style .plot interface, and previously it supported pandas or X-array or Dask objects. It now also supports GPU data frames from QDF and geographic data frames from spatial pandas. And so you can now use quite a large range of different data with hvplot. It's also, if you have the opportunity to see these slides or just search for linked brushing in holoviz, it allows you to create linked app plots and apps almost with zero effort. It just connects everything up that shares the same dimensions. It's really cool. Definitely try it out. Last one to cover is Data Shader. Everything on the right here is user contributed things I just grabbed off our Twitter feed during COVID. It looks like people are spending their COVID time exploring with Data Shader and having a lot of fun. Check out those examples. For instance, this colorful red and yellow one, that's a baseball diamond showing the positions of everybody in an entire season in Major League Baseball. All sorts of other examples. Anyway, now Data Shader supports Dask and CUDA for GPU data. And
we're getting to time, James.
Okay, I'll get to the last bit, just to leave that on the screen there. So if anybody has more stuff to get to, check it out there.
All right. Thank you, James. Our next speaker is Oscar Benjamin, who will be telling us about SciPy. While we get recursive screen displays. All right. So thank you. So take it away, Oscar.
Are you doing the slides for me, or am I sharing the screen?
Can you please share your screen? We had chaos at the beginning, and I think I failed to communicate that we're changing plans.
We're changing plans, so I should share my screen.
Yes, please.
Okay. Can you see that?
No.
No.
All right.
You got that?
Yep. It is now visible, and I will get out of the way.
Thank you. So I'm Oscar Benjamin, and I'm here to talk about SciPy. I'm presuming most of you know what SciPy is, but I'll just briefly explain. You can see here the SciPy logo. It's a Python curling round some sort of box that has some maths on it. So snakes are famously bad at algebra, and so they want a computer algebra system to help them, and that's what SciPy is. So SciPy is a library for performing symbolic manipulation in Python. It's a pure Python library, and we use it when we want to solve an equation and get an exact analytic answer. And so we have some pictures here. So on the left, this is what it looks like when you use it in a terminal, which is how I normally use it. And on the right, this is what it looks like in a Jupyter notebook. And so you can see we can solve polynomials, or we can integrate expressions or differentiate them, and many other things. So the aims of SciPy is to become a full-featured computer algebra system, which is a very broad aim, and I think it's going to take a long time to get there, but SciPy is very, very usable right now. So the core capabilities that we have in SciPy: basic arithmetic, simplification, trigonometry, polynomials, all kinds of manipulations with polynomials and other things. And also the big ones at the bottom here, calculus and solving equations. This is one of the big things that people like to use SciPy for. And then many more things here, matrices, plotting, and so on. So just moving on from the basic features, I had to collect some statistics here because I'm updating an old talk. And what we see is that now SciPy has had 800 contributors in the last 15 years and has grown to 750,000 lines of code. So it's really quite enormous. And actually, the biggest change since the last time this talk was done is that there are now 1 million monthly downloads on PyPy, which I think is a reflection of the fact that SciPy is now used very widely as a base for other projects. At the moment, right now, we have 6 GSOC students working through Google Summer of Code on various different things. And I don't have time to talk about them all, but there's going to be major improvements in all of these areas. So number theory, vector integration, ODE system solvers, and we're going to have a new control theory package coming. And there's been some major fixes and improvements in the evaluation of limits and series, and also extensions to the stats module. So that's where we are now. There's other major things ongoing at the moment. We're getting more and more matrix routines all the time, and we're getting solvers are getting faster and faster for solving equations. And many new things are on the way, such as the new assumptions, which has been going on for a long time. And we've also got some major work on code cleanups and docs and other things going on. So I think I'm running out of time after the confusion at the beginning. So I'll just say, please do give SciPy a try. Feel free to ask some questions in the chat where I'll be for the moment. And many thanks to Amit Kubar, whose slides I adapted for this talk.
All right. Thank you, Oscar. Next up, we have Melissa Mendoka, who will be telling us about NumPy. And I'm sorry. Oh, great. We have Melissa's here saving me from trying to be funny for 30 seconds. All right. So take it away.
Thanks, everybody. I'm Melissa. I'm here to talk about NumPy. In this past year, NumPy has had 2 releases, 1.18 in December and 1.19 was just released in June. As of this version, support for Python 2 has been removed, which I'm sure many people are happy about. There has also been some organizational improvements for NumPy. Together with OpenBLAST, we have received a grant from the Chan Zuckerberg Initiative, which has allowed us to do some maintenance and community building work. A brand new website has been released. If you haven't checked it out, you can do so. We are having weekly community meetings and bi-weekly documentation team meetings. And we've had a good number of people show up for those meetings, which is great. It's a great way to improve on our community. We have also just released a user survey, and you can check it out using the QR code there. And I'll also post a link in the chat for Crowdcast and in the Slack channel for the conference, so you can check it out later. It would be great to have responses from a large number of people, so you can check it out. As part of these organizational improvements, we have now dedicated website and documentation teams in addition to the regular maintainers and contributors team for the code. And so this has been a great year in terms of community building, and we are hoping to increase the contributor base even more in the next year. Some highlights. Our new website is much prettier and much more organized than the previous one. The website team has done an amazing job of showing NumPy's contribution to the scientific community. If you haven't checked it out, like I said, you can do so. It's numpy.org. You can find case studies and examples and integration with other libraries, with the whole scientific stack for Python, and it's really great. We have also started working on a documentation restructuring, and this has been detailed in a NumPy enhancement proposal, NEP 44. And we are hoping to increase the number of user-oriented content, such as tutorials and how-tos, to our official documentation. We are also working on allowing people to submit Jupyter notebooks with educational content to our documentation, and hope this will increase engagement with users who are not yet contributing to NumPy. On a more technical side, there has been a lot of work on including type annotations to the code base. This was being done in a separate repo, but has now been merged. So this progress has been ongoing in the main repo, and it's expected to be included in the 1.20 release. Another highlight is the work being done to improve SIMD optimizations, to simplify vectorization on different platforms, and optimize the ufuncs mechanism. This is an ongoing work, but has seen a lot of improvements in the past few months, but there's still much to do. Finally, we are looking to work on improving performance and interoperability in the next few months. We hope to also improve our documentation and user guide, continue working on maintenance, especially on submodules such as F2Py and FFT, and expand the work on a D-types refactoring, which is ongoing, but that's still early stages. So we hope to see a lot changing there in the next few months. Thank you.
All right. Thank you, Melissa. And next up, we have Madikin to tell us about YT. I guess I would like to just thank all of our speakers today who've been very good about staying on time so we can get through everyone in this session. And I will now get out of the way and so we can hear about YT.
Hi, everybody. My name is Madikin Monk, and I'm here to give the update for a project that I work on called YT. So for those of you that are not familiar with YT is a Python package to analyze and visualize volumetric data. We have the ability to read and ingest variable resolution mesh, fixed resolution meshes, particle-based data, and many other types of data. And we take sort of bespoke front ends for each different type of simulation code, and we ingest it so that somebody can just say, load my data set. They don't have to do any pre-processing. YT will load it, and then they can create beautiful visualizations, or they can do analytical operations like slices or spheres or other types of operations on their data. So we have a couple of new updates that I'm really excited to talk to you all about. And so first, I'm going to talk about our main release this year, and then I'm going to talk about what's coming up for this coming year. So we did our last release in the 3 series, YT 3.6, and that's our last release before 4.0. There's some really cool new features that are happening in this particular release. We have support for CartoPy, specifically the geographic transforms and projections. So now you can work with geographically and geo-registered data sets. We can export regularized grids to X-ray. We can operate and export any data objects from YT into AstroPy Q tables, Pandas data frames, and also Firefly. We have built out some support for visual annotations to curvilinear data sets. Some of our original annotations were primarily for Cartesian data sets. And we also have built out some new front ends for other simulation clones, including AMRVAC, Adaptahop, and Gamer MHD. We had many contributors to YT 3.6. About actually half of those new contributors, were new and contributed for their first time. And we've bolded all of the first-time contributors to YT 3.6. We thank everybody who contributed to this release. It was a really big community effort. Now, moving forward, we're going to YT 4.0. We're doing a lot of new things for YT 4.0. We had a kind of divergent development branch because some of our particle-based algorithms were very divergent from the 3 series. So there's going to be a beta release coming soon to a computer near you if you're interested. We are relying more heavily on a lot of styling processes and things like that. We're doing a lot of community building. So we've updated our governance structure and some of our website related to community building. We're also having weekly community calls for development and triaging. And we're refactoring some of the code that's duplicated in our front ends. We also have some algorithmic improvements. A lot of our stuff is related to volume rendering. So we are building out some volume rendering of octree data sets, and we also have support now for different types of fields being visualized in our volume rendering.
We're almost at time.
Sorry, yeah, I'm very bad at time. Sorry, everybody. And finally, we have some curvilinear volume rendering, and we're building out support for Jupyter widgets. And we're also building out more front-end support, specifically for some geographic data. Thank you, and I'm sorry for going a little bit over.
It's okay. So I just want to thank all of our speakers. It is now something 31, depending on where you are. So that is the end of this session, and hopefully you will all join us in the next session. If I can figure out how to end broadcast. Thank you.